Hey there, ladies and gentlemen. In this tutorial, which I'm gonna call it the ultimate tutorial, I'm going to show you how you can estimate spatial panel data models in Stata using a command called xsmle. And this is probably going to be a long video, just because I want to cover everything you need to know from beginning to the end, so you can do this successfully and at ease. In the description of the video, I'm going to include every material I'm going to use in this video. I'm going to be showing an example on how to do this. So this includes the commands I use in Stata, which is a do file, and every instruction basically that I'm going to use, so you can successfully estimate it on your own if you want to follow along, or for your own study that you're probably struggling with. So, without further ado, let's begin. As you probably know, in order to estimate spatial panel models, you will need to use a spatial weighting matrix. In this tutorial, I'm going to use the GeoDa software to generate that spatial weighting matrix. And I'm going to demonstrate everything I'm doing using the example of the Portuguese municipalities. So they are the spatial units of this example, the Portuguese municipalities. And you can find shape files wherever you want in the internet and download them for free. So there's shape files for pretty much everything, and I found a shapefile with the Portuguese municipalities, so that's what we're going to use. I'm going to include this in the description as well. So if you don't have GeoDa, you have to install it. If we open the internet, and this is a free software, just search on Google the first website, and it's this one that you want. It will redirect you to another website, and then download. From here you want to download for whatever thing you have. I have a Windows PC, so I would have to click here and then install it, but I already have it installed, so I don't need to worry about that. Let's open GeoDa once you've installed it. As I've said, our data source will be the shapefile containing the Portuguese municipalities. So I'll just open it. It's in the tutorial folder, right? And this includes the map with the 278 municipalities. Each municipality has a unique ID, and you can check the ID if you open the table, and the table shows the 278 municipalities. You know, the ID is a number and the name of the municipality, and you can notice it's in alphabetical order. In this case, I can't be sure about the shapefile you're using, but the order that is in the shapefile is very important, because that's the order you're gonna follow in your estimates in Stata, so you need to keep an eye on this. To create the spatial weights that are gonna set the neighbors for each municipality, we'll click here. Now we're gonna create them, and the ID variable is the poly ID in the shapefile, in this shapefile. So here we can choose the type of spatial weighting matrix we're going to generate. It can have it can be of the form of contiguity or distance. In this example, we're going to choose contiguity weights and a queen contiguity of order 1. But if we open the folder of the tutorial, you have a picture that says contiguity, and you have the two main contiguity types. Under queen contiguity, neighbor relationships occur between municipalities that share common borders regardless of border length. So it can be edges, or it can be corners. On the other hand, in the Rook case, Rook contiguity, neighborhood relationships occur between municipalities that share common edges only. So you see that this one is not the neighbor of this one, because they only share a vertex. Okay? So you create the one that makes the most sense in your study, right? But anyway, we're gonna do queen contiguity and we're gonna create. Let's save it in the desktop, for example, and we're gonna call this weight. Is this right? Weight file. So we get a warning saying that there is at least one neighborless observation, so we have to look at that and see if it's correct or if we have to fix it. And we created this file. This is a very important file, GAL, this is what we're going to use in Stata later on. Okay, we can close. So the type is queen contiguity and so on. We can open the connectivity map. And notice here, wherever I have my cursor on, if you look at the bottom left corner, you see that this is observation number 199. So I could easily, if I open that table, I can see the name of the municipality that is corresponding to. And it has 5 neighbors, according to the weights that we just created. The number 64 and so on. And this seems about right. And this one seems about right and so on. So how are we going to detect the neighborless observations? One way to do that is go here on space, univariate local Morans 1 for the IDs. This doesn't make economic sense, but no, it doesn't matter right now. Click on cluster map, and here we go, neighborless, 2 observations without neighbors, and it's this one and this one. So should they have neighbors? Of course they should. Look here. Bottom left corner again, observation 42 should have observation 53 and observation 154. So we need to add these neighbors to each other. How do we do that? Well, we just created the weights. Just open with Notepad. Okay. And the way you can correct this is observation 1 has 9 neighbors and these are the neighbors. Observation 2 has 9 neighbors and these are the neighbors. Observation 3 has 5 neighbors and these are the neighbors, and so on. So we're going to edit manually the ones that are missing. So let's check again. Observation 42 has 2. We have to add those 2 neighbors. So it's 42. Where is 42? We're gonna change from 0 to 2 and we add the neighbors 153, 154, 153, 154. So we have to go as well for 153, and we have it's 6 neighbors, not 5, and we have to add 42. And here it's 4 neighbors, not 3, and we have to add 42 as well. Does it make sense? Now, the second problem, neighborless observation. How many neighbors should it have? 21 should have 72, 211, and 19. So it should have 3 neighbors. So let's do it quickly. Observation 21 should have 3 neighbors, 19, 72, and 211. So observation 19, where is it? Should have 6, not 5, and it's 21. And observation 72 should have 9 neighbors, 21. And observation 211 finally should have 10 neighbors, and we have to add 21 here. Now, is there another problem? Sometimes there is, so you have to be careful. Let's open the contiguity map again, connectivity map again. I found out from careful analysis that this one is missing and this one is missing. They're each other, you know. So even though the surrounding neighborhood municipalities have correct neighbors, this one and this one are missing each other. So let's fix that. Observation 214 should have observation 165, and 165 should have 214. So 165 should have one more neighbor, which is 214, and 214 should have another neighbor, 165. Okay, we can save, and we're done with GeoDa for now. Okay, so let's move on to Stata, shall we? If you open Stata, using Stata we can import the information contained on the weights file that we created on GeoDa to generate a spatial weighting matrix that is usable in Stata. To do that, we must first do a very important step, which is to change the working directory, and we're going to change it to this desktop. Okay, so I have here in the tutorial folder a command text file with the commands that we're gonna input on Stata to make it easier for you to follow, right? So let's install this module. Obviously, for me, it will say that it already exists, so we don't need it. But for you, you need to do this. Okay. Now the next step is to run this command, and we're gonna import the weights file, and we're gonna make a text file with the weights in a way that Stata can read them. So here, obviously, the directory you have to change to where the weights file is. So let's move the weights file to the tutorial like it is in the command, and here user, you have to put your own user. I'm going to show you quickly how you find it in case you don't know. It's pretty basic. Go to users and it will be here. In this case, for me, it will be utilizador. It's Portuguese for user, but it can have another name. It can have your name. I don't know what you set it up to, so just do that. Okay, now we're yeah, I thought I did the name of the file wrong. Okay, it's weights file that is in the command, not weight file. Okay, let's just do the command again. Let's pick it up, this one. Copy, paste. Okay, we created the spatial weighting matrix. Let's check it. It's in the directory where we said it would be, in the desktop, and it's the zeros are where they're not neighbors, and 1 is, so observation 2 is a neighbor and it has a 1, and the others are 0 until it's another neighbor, and so on. The last line, we don't need it. Let's delete it. Let's delete this first line that we don't need it either, like this. We can save. Let's move it to the tutorial folder. We have to transform this text file into a readable Stata file, which is the data file in Stata, and it's this one. So to do that, we're gonna run another command, and we're gonna save it as a DTA file. So here you change do your own thing. Let's press enter, and it's saved. So let's check it. As you can see, it has 278 variables, which is the number of the municipalities, and it's balanced. But we're missing the ID variable. How do we add the ID variable? Let's generate it, and you run the second one to if you generate it, it will appear on the last column. We do this one to make it appear on the first column. Okay. Now, later on, we're going to need this data file not to be called variable 1, variable 2, because it is for the data variables, not for the matrix. So for the matrix, we call it M. So we're going to change the names like this, from V to M in the 2 digits and 3 digits. So imagine your data has thousands of observations. You need to put 4 digits at another line. Okay, let's check it, and it's been changed. You see? Now there is a problem with the data that I identified. You see here, this first ID says it has a neighbor for the second observation, but if you let's go here, if you look closely here, not here, on the gal file, the first should have only an observation on the 72. So what I noticed is that the files are inverted. So the last observation has a neighbor on the second observation, and 167. So let's check just to show you. 167. You see, and a 1. And if you go check, it's all inverted. So this last one only has where is it? This first observation should have a first neighbor on 72, and it will have on 72. It has a 1, and so on. So how do we make sure the order here that is wrong, because it's not the order in the shapefile? How do we correct it? Well, or the order in the gal file, which is the same. So we have to correct this. I don't know if your own shapefile will have this problem, so this is not a mandatory step. It's just if this happens to you too. Okay. So what we're gonna do is actually, let me explain. We're gonna sort the ID variable upside down. So all the data has been turned from ascending order to descending order. Now we don't. Now the variables, the data is correct now, but the ID variables is all messed up. So we are gonna delete the ID variable, and we're gonna add it again. We add it again, and now it's perfect. So for the first, it should have on 72, for example, you see, and so on. So now it's fixed. All right. Now we can save the data. Let's save it on the tutorial, and we can save it as so let's save. So yes, let's just overwrite this. Yeah, sure. For weights. Is it saved here? Weights, DTA. No, it's saved on here. So let's move the DTA file to the tutorial folder. Okay. So another break from this, before we estimate the spatial panel data models, before we run the regressions, we need to make sure that our data, in this example I'm going to use this one, is in panel data format. And as you can see here, it is in the panel data format. So you have municipality 1 for years, for the years of the data, municipality 2 for the years of the data. So this is what panel data format looks like for the variable 1, 2, and 3. But I know this can be a pain. This is actually the most time-consuming part for anyone that's trying to change like how the normal variables look like, the data, into panel data. So I'm gonna include in this part of the video now a way to change the format of your normal data into panel data. So I have a file here, and you can skip this step if you already know how to prepare your data into panel data format. But we're gonna do this. I have here a file, Excel file, with the normal variables that are not in the right order, so they're not even usable for cross-section data. And then, so we're going to convert it into the right order. So you can see here that the order it follows is not alphabetical like in that shape in the GeoDa file, in GeoDa IDs, and so we have to make it look like that. And the year is the year is 2015 to 2008, so it's not changing for each municipality, you know. So we have to change. Let's start working on this. First of all, you remember on the other file that is already prepared, we have a row we insert here with the year, and it doesn't say 2015 or 2008, it says 1 to 8. So 2015 will be year 8 and 2008 will be year 1. So there is what you do is for 2015 you put year 1, 2014 you put year 7, and so on until year 1, which is the last data. So I'm gonna talk to you in a bit. Okay, once we've done this step, we no longer need this. We didn't even need this. This was just to show you that it was following this signation. So now that we've done this, we want to copy the titles into the right, so we can put it on the right order. These municipalities that are following in kind of a random order into the right order that is in GeoDa. I have a file here with the municipalities in alphabetical order. So let's just copy, paste, and this will be for year 1. So you double click here and it goes all the way down, and you can do this again for year 2 and so on. So now that we've done that, we want this to be year, not year, with a cap. Let's delete this one. So now that we've done this, we're gonna select everything, but first we need a add-in actually. So there is an add-in that allows you to merge the information from two tables. We want to merge the information here into here, so we don't have to do it manually or with formulas that take forever. So there is an add-in that I'm going to show you, which is called Merge Tables Wizard. I'm going to put the link in the description. And this is a free add-in in the first 7 days if you use this link. So you can fully use it for 7 days for free. Just download this and install it, okay? Install it for your Excel. So click on the first cell, go to the end. Actually, we need to know when it ends. Let's check. It's AD. So go to the end, AD 225 AD. Hold Shift down and click on this cell. Okay. Now let's do the same for this one, where we want to look up the information. Click on the first cell, go to the last cell, hold Shift, click on it, Okay, now go where you want to fill in the information. Let's merge two tables, click on it. Now we want to click next. You want to pick up information from here, so next. You want to match. The ones that are matching is the year column and the name of the municipality. And you want to fill in all these variables. Oh, actually, fuck. Yes. Oh, let me just. We don't need this column anymore. Okay. Let's do it again. Merge. Next. Next. You want these two to match. You want to fill all these variables. Okay. And just like that, it's done. There are no errors, so it adds here saying it's updated, so everything is okay. You can delete the backup page because everything went smoothly. Okay, so what we have here is in cross-section. It's cross-section data. So let's name it like that. This is usable in the GeoDa if you would want to run the GeoDa regressions, for example, for each year. But that's not what we want. We want panel data. So again, let's copy these titles here. And the difference from cross-section data is that you want let's put this municipality like in that data. You want these ones not to be all changing, and you want these years to be changing. So this is municipality 1, this is municipality 2, 3, and so on. A fast way to do this is like this: equal to the previous one plus 1. So let's go to the first year. Let's select it again. Now there is a formula. We want to get rid of that formula, so let's copy and then paste it with the 1, 2, 3. So the formula is gone. Now we want to paste it again here for year 2 and for the following years. Okay, perfect. We don't need this anymore. We know it's following the GeoDa information. So instead of this one, we want to put this like this. Notice that this is cross-section data. For panel data, it will be like this: 1, 2, 3, 4, 5, 6, 7, 8 years, and the years here will be changing: 1, 2, 3, 4, 5, 6, 7, 8, and so on. Like here again, 1, 2, 3, 4, 5, 6, 7, 8, and here it will be municipality number 2, and then number 3, and so on. So a quick way to do this is convert to this one plus 1. And let's do it let's drag this formula for the same number of lines as the cross-section data, so it matches, so it fits right in. And it's 2225, I believe. So let's copy this because it has a formula and paste it with values, so the formula disappears. 225. Let's just make sure it's correct. Yes, 2225. Okay. For the years, I don't think there is a fast way to do this, but we can do it like this. Just keep copying and pasting. So obviously we went too far, so let's just select like this, and let's delete these lines. Okay, we're good. Now we can again use the add-in. So let's click on the first cell. Let's go down to the 2225. I think it's AD. Hold down Shift and click on it. And here, go to the first one. Hold down Shift, click on it. Merge tables. Next, we want to pick up information from the cross-section page. We want these two to match, and we want to fill in for all the variables. So no problems again, do it really fast. We can delete this, and we can delete the backup page. So, and this is what panel data looks like. Spatial one with for all the years and so on. Okay. So let's keep going. We don't save this because we're gonna use the file that is here, which is a simpler file. We're almost ready to run the xsmle code. Let's first import the information in the Excel file into Stata. Go on File, Import Excel Spreadsheet, Panel Data. Make sure you click on this one. So the first row is the name of the variables. You see that there is data here, like already here, from our spatial weighting matrix. So let's first clear. And let's do it again. Import Excel spreadsheet. Okay, now there shouldn't be a problem. Let's save. It should be here, the new thing. Let's save. And we can call it panel data. Okay. Now that we have this done, there's only, I can close this. We need to install 2 more packs so we can run the command. You have to do it, not me, because for me it's already installed. Okay, they already exist. Now that you have installed these 2 models, let's use this command right here to estimate the spatial panel data models. Now, we don't need this anymore, but I have this in the tutorial folder. I have this code.du, which have the commands saved for the estimations, so you don't need to worry about that. And the way to open it is you click on here, and then let's open it. Now everything in here is already built, so you just need to run. The only thing you need to change is this thing, so you have to change to where it is. Well, everything is. For me it's already correct, it's all in the tutorial folder, but don't forget to change your user to the correct one, and here the same. Okay, so let's look into this quickly. This is why you install the spmat command. This is the name of the weighting matrix that you're going to give. This can be anything. I'm going to put W just because. This is why you don't put V, and we changed it into M, so it recognizes the rows with M. Normalize it, and then here are the descriptive statistics of the spatial weighting matrix that we're going to ask Stata to do. Now we're gonna use the variable data, the data for the variables. The ID variable is the municipality, and then this is all in the Excel file. It's all from the Excel file. This is the dependent variable, and these are the independent variables. In the file, it's this name, you know, but you can change it for whatever. Imagine your variable is called wages. You would put here wages, and then the independent variables there are something else. You can change that, you know. So we set it as panel data, so Stata recognizes it as panel data. These are the summary statistics, descriptive statistics of the variables. It's common to ask Stata to estimate a non-spatial panel model, and it's the pooled alias estimator that we have here. This is that IC is to ask for the AEC and BAIC criterion. It's basically to compare models to see if it's a good fit for your data. The lower the number of these criterions, the better the fit for the same data. Now we have the spatial panel models. The STM model, the SAR model, the SEM model, the SAC or SARR model, the GSPRE. These are all estimated with the xsmle command. And then we have a section for model selection that I'm going to show you later where I took it from. But it's a simple test to see if the models that you should be using are the STM or the SAR or the SEM. For other, for example, to test if you want to use the SAC or the STM model, or the GSPRE or the SAC model, you just compare the AIC and BIC criterions. So, or you can also look at the R squared, the higher the better, obviously, and the log likelihood, for example, also the higher the better. Depends on what the literature tells you for each case. Now, let's look into how you actually type in the xsmle command. You put the dependent variable first, and then the independent variables. Okay? And then you put the model that you want, and then this is random effects, and this is fixed effects. This is fixed effects with the data transformed to Lie U, according to Lie and U. This is for time fixed effects, time and spatial fixed effects, no effects. And we also do the robust Hausman test, so we can see to test if we should use the random effects or the fixed effects. What else? I can talk about an option that is not mandatory, but I included it in every specification, which is the VCE, which is you put it there. So in the regressions include robust standard errors estimations and robust variance estimations, which take into account cluster correlated data for the variable that you specify, and it basically adjusts for within the cluster correlation. And it's a famous this robust variance is famous. It goes under the name of Hubbard-White sandwich estimated variance. So we are ready to run this command, and we click there, and let's just see Stata. When you see this running, it means it's thinking. So I'll be back when the code is all over. Okay, so as we can see, the do file was successfully executed. There are no errors whatsoever for every type of xsmle command. There were no problems. So let's just analyze it very quickly in case you don't know how to do it. As I've said before, we asked for a summary of the spatial weighting object. That's why this is what we created in GeoDa, and then we imported into Stata and every model specification includes at least one spatial weighting matrix. So that's why it was so important to generate it. Otherwise, you cannot estimate spatial panel data models. Here we have some statistics of the spatial weighting object. You can see that in the mean number of neighbors is 5.3. This is number of total links, the minimum maximum number of neighbors. One observation has one neighbor, 17 observations have two neighbors, and so on. 2 observations have 10 neighbors, and here they discriminate which are the observations that have 10 neighbors and 1 neighbor. Now we ask for a summary. So it's a panel. Our panel data is strongly balanced. We have a summary, descriptive statistics of the variables. So overall variation is the variation over time and over municipalities. Between variation is the variation between municipalities from one municipality to the next. And the within variation is the variation over time within municipalities. Some statistics for each variable. This doesn't have economic significance, so I just chose the variables randomly. So pulled all the estimator done for the dependent variable. So we have the independent variables here, the coefficient and the p-value. So here they're all statistically significant, even the constant with this coefficient. So as for the STM model, and each spatial panel models have the coefficients, and then they have this. In the case of the STM, they also have another not as important coefficients. So, but they always have some type of spatial dependence coefficient parameter, and this is very important. This is why you estimate spatial panel models. So in the case of the STM, it's a Spatial Rho, but in other cases it can be a Spatial Rho, a Spatial Lambda, Spatial phi, depending on the model specification. And they show us the spatial dependence present in our data set. So in other words, they measure the average influence of the neighboring spatial units on a given spatial unit. If there are no spatial effects, then this will not be significant, but apparently, and for this data, this one is. So another preliminary analysis that usually you do before estimating spatial panel models is to use the Moran 1 test and the Lisa cluster statistic. And you can do that in GeoDa very easily with cross-section data, not with panel data, but you can do it for each year. But before I forget, I want to show you the paper that was published this year in the Stata journal, and let's see if it opens. And you can go into more detail for the command that we used. This is all about the xsmle command. You see, so for example, we saw for the model selection, they explained here why we do those tests to distinguish if it's a STM or SEM or a SAC model. and so on. You have to, if you want to take a look at this, I'm going to include the link. It's open source, so it's free to download. So I'm going to include this in the description, as well as all the all of these files. But I think that is it for this tutorial. Thank you so much for watching. I hope this was helpful to you, and that's it. I will see you in the until next time.